Alrighty, Hydron FC1 launching in 5, 4, 3, 2, 1. Come on. Sweet, that was pretty good. Hey folks, Nathan here. Well, it's finally happened. Our FC1 flight computer has had its first successful flight. We did have to fly it on a Hydron since the Aquarion sprung a leak, and we still need to build a new one of those, but it's still done its job quite well. Also, technically, the FC1 computer has been performing admirably in every single test it's done, and it's been the parachute that's the issue, but regardless, with a successful landing, the FC1 is now rated as flight ready. Let's take a look at the launch. Isn't that a wonderful thing to see? The fins are quite clearly straight as it's flying in a near straight line once it picks up speed. And there's still a couple of parachute kinks to work out, and we can see that the chute opens here, but it isn't until here that it actually opens up, which is a little too close to the ground for my liking. Looking at the readout, we made it to a height of 23 meters, which, given the size of the rocket and a 250 gram dry mass, is actually not half bad. But onto the issues that we've been facing. The main issue we're left with now is that the FC1 wasn't able to do a second flight. During the landing, something came slightly loose, and while the Arduino was able to power on with no issues, the LED was only sometimes coming on, and if you'd move it slightly, it'd go on, go off, go on, go off. So since we weren't able to verify the integrity of all the other sensors, we had to scrub the future launches for the day. The FC1 has been sitting on a shelf for over 6 months now, so it's not the most surprising that something came loose, given my relatively amateur soldering skills. Outside of tightening up the soldering a little bit, the circuit board needs to be firmly attached to the rocket. Right now, it continues to come loose, whether it's held in by glue, or taped on, or whatever I do to it. This means that our next major phase is going to be all about improving the payload bay. Right now, everything's attached to a single piece of foam in the middle that's suspended from the top of the bay, and we can definitely do a lot better than that. If you have any ideas, I'd love to hear them in the comments. I am staying away from 3D printing for the time being because this part of the project is all about using simple manufacturing and anyone being able to jump in and do it without any major investments. So yeah, I don't have any ideas yet on how to do it outside of using a lot of tape, but we'll see what we come up with. Moving on from the rocket itself though, let's see how our simulator went. As you can see, it provided a value well under what we'd expect. I looked into a bunch of different simulators, and they all gave some pretty varied results. I think the largest factor in them though is the drag coefficient of the rocket. I assumed a drag coefficient of 1 in all of these tests, but the rocket itself is likely somewhat below that. In the course of figuring all this out though, I did learn that there's a math issue with the simulator, which means that the results are unlikely to be accurate in the first place. The simulator doesn't provide the correct result that you'd expect when the ratio of water to air is unfavorable, so something's very clearly going wrong. I'll probably need to rewrite a bunch of the math from scratch, or possibly even look into other formulas that are used in other simulators, but that's an issue for a future video. That's all for this video though. Our FC1 computer is successful, and we need to work on securing our payload bay. If you'd like to build your own FC1 computer, then this video up here will fully explain every line of code. Otherwise, see you in the next one.